The aging of the gastrointestinal system is often described in terms of slower digestion, increased susceptibility to inflammation, impaired nutrient absorption, and higher risk for conditions like diverticulosis or inflammatory bowel disease. Yet much of this so-called gut aging may not be an intrinsic deterioration, but instead a preventable and reversible form of ecological collapse brought on by chronic deficits in dietary fiber. The colon is home to trillions of microbes forming the gut microbiome, an ecosystem that relies heavily on the constant fermentation of indigestible plant polysaccharides. When these fiber-based substrates are lacking due to modern low-fiber diets, the microbial balance shifts toward less beneficial species, a state known as dysbiosis. This change impairs gut barrier integrity, increases systemic inflammation, and reduces the production of short-chain fatty acids, SCFAs, especially butyrate, which is essential for colonic health. Viewed through this lens, the degeneration of the gut with age can be more accurately understood as the long-term consequence of fiber malnutrition, rather than a programmed biological decline. In a well-nourished gut, dietary fibers, especially soluble types found in legumes, vegetables, fruits, and whole grains, are fermented by beneficial bacteria such as Faecalibacterium prosnitziae and Bifidobacteria. The fermentation process produces SCFAs like acetate, propionate, and butyrate, which play crucial roles in maintaining gut homeostasis. Butyrate, in particular, is the primary energy source for colonocytes, cells lining the colon, helps tighten the gut barrier, and exhibits powerful anti-inflammatory effects by modulating immune cell activity and suppressing NF-B signaling. In a fiber-rich environment, these beneficial functions are sustained, and the intestinal lining remains resilient, well-nourished, and immunologically balanced. However, with prolonged fiber deficiency, the gut microbiota shifts towards species that degrade mucin and produce endotoxins, such as Escherichia coli and Bacteroides fragilis in excess. These organisms thrive when dietary substrates are scarce, resorting to breaking down the mucus layer that protects the intestinal lining. The result is erosion of the gut barrier, commonly referred to as leaky gut, and the translocation of bacterial products like lipopolysaccharides, LPS, into the bloodstream. This triggers systemic low-grade inflammation, a hallmark of many age-related diseases including insulin resistance, cardiovascular disease, and neurodegeneration. But this inflammatory cascade is not the product of age alone. It is rooted in the absence of fermentable fiber and the metabolic starvation of protective microbial species. This understanding reframes gut aging not as inevitable entropy, but as a form of microbial malnourishment. The gut ecosystem is dynamic and reactive. Its composition and output are determined not by time, but by what we feed it. Studies in both animal models and humans show that switching from a low-fiber, high-fat Western diet to a fiber-rich, plant-diverse diet can reshape the microbiota within days, restoring populations of SCFA-producing bacteria and reducing markers of gut inflammation. Moreover, elderly individuals with higher fiber intake tend to have more youthful microbial profiles, lower systemic inflammation, and better cognitive and metabolic health, despite their age. The reversibility of microbiome aging through diet is among the clearest examples of how biological resilience is preserved when nutritional inputs are optimized. Fiber is not simply roughage, it is the primary currency for microbial health and, by extension, for systemic metabolic equilibrium. When fiber is absent, the microbiota responds as any ecological system would in a drought. Diversity collapses, harmful species rise, and the foundational services provided by the ecosystem begin to fail. But when the drought ends, when fiber returns, this system can regenerate, recover, and resume its protective roles. It is also worth noting that microbial diversity is a key predictor of health span. Older adults with greater microbial richness tend to maintain better mobility, immune function, and even cognition. This diversity is directly influenced by the variety of fibers consumed. Different microbes ferment different substrates, and only a diverse diet can support a diverse ecosystem. Prebiotic fibers like inulin, arabinoxalin, pectins, and resistant starches each feed distinct microbial pathways, contributing to a robust and multifunctional gut flora. Modern diets, which often exclude legumes, tubers, and intact whole grains, fail to provide these substrates, resulting in a slow erosion of microbial resilience. Ultimately, the concept of gut aging is less a biological inevitability and more a nutritional outcome. The microbes that support human health are not passive bystanders. They are symbiotic partners who rely on our dietary choices to thrive. If those choices chronically exclude fermentable fibers, we degrade that partnership, and with it, the structural and functional integrity of the gut. But the gut's decline is not irreversible. With fiber repletion, microbial recovery can occur even late in life, restoring gut barrier function, reducing inflammation, and enhancing nutrient synthesis, including vitamin K2, folate, and short-chain fatty acids vital for long-term health. So in truth, gut aging is not a countdown, but a feedback loop. The intestinal ecosystem reflects what we nourish it with, and when fiber is consistently present, the gut remains youthful in function, even in an aging body. This shifts our understanding away from deterministic aging models toward one rooted in ecological restoration. Aging of the gut is not an unavoidable breakdown, but a preventable and often reversible form of microbial malnutrition. Feed the gut, and it will, quite literally, regenerate us.